Just go to this third option, metric SI, Indian, IS 800 2007, IS 456 2000 basic codes will be there. Let's say simply OK. Once you click over this OK, now the grids. So tell me, which option you would like to prefer? Either making the grid lines in the ETABS software itself or export and import. Making the grid lines in the ETABS software itself, because it's a very simple geometry is there. Because very simple geometry. If the architectural geometry is or structural framing plan is very, very complicated, in that situation, you have to look at the export and import method. But experts recommend that as much as possible, you should try to go with the ETABS quick template option, means making the grid lines in the ETABS software itself by using the quick templates. So if I'm going to look here, so 1, 2, 3, 4, 5, 6, 7 number of grids are there in X direction. So I'm going to put here as, and one more thing, I would like to see here, this grid system is non-uniform grid system, because the spacing between these two grids or grid lines is not same. Here 4, here 3.5, here 5.7, here 2.1, here 3. So it is what random spacing is there. Uniform spacing like 4, 4, 4, 4, 4 is not like that. It is what non-uniform grid system. So I'm going, but the number of grids in X direction is what? A, B, C, D, E, F, G. So it is what? 3, 3, 6, and 7. 7 number of grids are in X direction. So I'm going to put here as 7. Coming back, and 6 number of grids in Y direction. So I'm going to put here as Y. 6 number of grids in Y direction. Very interesting, like spacing of the grids in X direction. So we know that it is the non-uniform grid system. So like this option is useful when your spacing is uniform. So like this uniform grid spacing is not completely useful. Yeah, if you are defining this number of grids and number of grids in Y direction, that will help you. So I need to go to this custom grid spacing anyhow. So just click over this, go to edit grid data. So as we have defined there as 7 and 6, so accordingly the number of grids will be present here, grid IDs. Another, you know very well, we are working with this second option. Check this option. This is the easiest one. Come back to your drawing. Now, distance between A to B in reference of A, it is the 4 meter. I need to go back to ETABS and put here as 4 meter. B to C in reference of B, it is 3.5. Just go it and 3.5. Come down. C to D in reference of C, 5.73. 5.73. Next, D to E in reference of D, 2.1022. If you want to exact dimension, so it's okay, no issue. 2.1002. Go back 2.1002. Otherwise, if you are taking 2.1 also, that will also be okay, no problem. Now, E to F in reference of E, it is 3.5. Put it here as 3.5. Next to that, F to G in reference of F, it is the 4 meter. So I'm going to put here as 4 meter. That's it. Coming back to this Y direction, and in Y direction, we are having these this much grids. So one to always remember, you have to put the dimension from the downside, from the these lower grids. You have to move from bottom to top and left to right. Always remember. So here, bottom to top. So grid 1 to 2 in reference of 1, 3.4219. It is actually what? 3.4219. Next to that, what will be there? B to 3, 2 to 3 in reference of 2, 1.0781. 1.0781. Just come down. And 3 to 4 in reference of 3, it will be 2.0565. 2.0565. Okay. Next, 4 to 5 in reference of 4, 1.8430. 1.8430. Next to that, what is there? 5 to 6 in difference of 5, 2.6256, 2.6256. Kindly mute your mic who is there. And next, 6 to next, in reference of 6, obviously nothing is there. So for the 6, the value will be what? 0. So for both of the end grids, the value will be 0 if you are working with the display grid data as spacing. This is all done. Now I would like to reduce the bubble size. Whatever the bubble size you are looking here, that will be what? 1000. I'm going to make it here. And the color I would like to take some dark color I would like to take. So make it as change. This is all done. And let's take OK. So whatever the things we have defined here, they are actually the in-plan definitions, the in-plan grid definitions. Remember, so I'm going to click over this in-plan grid definition. Just click over this OK. This is done. Now grids has been defined. Now overheight definition. Overheight definition. So very interesting and important things we are going to cover here. Please concentrate here. So overheight definition. So you know that it is the G+2 building. G+2 building. So like how you can decide the number of stories. How you can decide the number of stories. So that is very, very important point you should know. So like suppose how you can decide this number of stories. But before of that, I would like to ask a question to all of you. Okay, give me answer. Suppose, suppose a building is there. Suppose this is your foundation level. And this is foundation to your ground up to the ground. It is your ground. This is the first floor.
Welcome you all in ISO certified live training program ETABS, RCDC and Excel that makes you a professional structural engineer. In this training program you will learn everything about ETABS and RCDC from basic to advanced, real life project of medium rise structure from architecture plan to final design sheet, real life project of high rise structure with all advanced topics, design of structural elements using advanced Excel sheets. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now more than 1000 participants have benefited from this training program. Now you are the next.